Okay, so let's get through these last few examples, and then you should be set. I need to find x so that UVWX is a parallelogram. So these are two angles. It's kind of hard to tell, but this is one angle. That's angle U, and this is angle V. So they're two separate angles. That might not be the best way to mark that. Well, okay, so those are two separate angles. They are next to each other, which if they're next to each other, that means they are supplementary, guys. So the measure of angle U plus the measure of angle V, forgot my angle sign, is equal to 180 degrees. So I can take those two equations that they give me and plug those in. So 9x plus 15 plus 6x plus 15 equals 180. Combine your like terms and you get 15x plus 30 equals 180 degrees. Subtract your 30, you get 15x equals 150. Therefore, x has to be equal to 10. So as long as x is 10, then that is a parallelogram. All right, let's look at example 9. Okay, we have parallelogram that says we're going to try to find TE. So TE is a part of a diagonal. So I have a few diagonals here. And when I say a few, I mean two. So I have this diagonal, VE and ET. So I have two pieces, TE and EV. So those are the two pieces of my diagonal. So I'm going to put in TE is 4 plus 2x. EV, or VE, is 4x minus 4. Now, again, looking at your properties of parallelograms, which one talks about diagonals? The one that says diagonals bisect each other, so they cut each other in half. So what do we know about VE and TE? They are congruent. So VE or EV is congruent to ET. So I can just set them equal to each other. 4x minus 4 equals 4 plus 2x. We're going to shift things over and combine like terms. You get 2x equals 8. So x has to equal 4. Now, go back, read your question. Find TE. Wants to plug it in. So TE is being represented by 4 plus 2 times 4. 2 times 4 is 8. 8 plus 4 is 12. So TE is 12. And one last one for the road. We're going to find SQ. So let's see. SQ is also a diagonal. I'm going to give us another color here. It's blue. It's our diagonal here. We have ST, which is x plus 8, and TQ, which is 3x minus 2. And again, look at your properties. Which one talks about diagonals? I'll wait. You'll tell me. You'll shout it out. What was that? Oh, they bisect each other. So these two pieces are congruent. There we go. Congruent. So we can say ST is congruent to TQ. Their little hats. We can set them equal to each other. So we have x plus 8 equals 3x minus 2. Combine your like terms, shift things around. And we get, I'm looking at my funny math from a previous question. That's very funny. Move your 2 over and you get 10 and 2x divided by 2, and x is equal to 5. But am I finished? No, I still need to plug this back in. Plug it back in. So SQ is the whole length, guys. Hold up, the whole length. So make sure you are reading your question carefully. So it tells me SQ, so I need to find out the full side. So I could just plug this into 1 and double it. 5 plus 8. What's 5 plus 8, guys? That's right, it's 13. So if that's 13, 5 times 3 is 15 minus 2, also 13. So the whole length of SQ is 26. There you go. Get some homework done, guys. Thanks.